in data science or machine learning. Means machine learning is used mainly in the data science for the classification, like feature selection and then classification. So if we see data science or machine learning, then there are two things that comes into it. Data science or machine learning is nothing but a predictive analysis where we predict something. So based upon our past experience, then we predict something. So based upon the past experience, we calculate a model. I mean, these are fancy terms, but in mathematics, we come to a kind of formula. So if I have a set of points and then I have set of points, then I can find that one particular point falls on this line or not. So set of points, it constitutes a line, and a particular point falls in a point or not. So the best way is we calculate the equation of the line. So mathematics comes and we come to a formula, and then we see that a particular point that is in question that satisfies this formula or not. So that we can say we created a model and this is what it is. So this is how the machine learning is. So if I have set of data, then I constitute a line or I constitute an equation. I kind of think about a formula, or I can say I created a model. Once model is ready, then I can predict something. Okay, so or I can predict that this particular line falls on which side, and based upon that, we can do some kind of prediction. We can kind of fortune telling. We can say, so that is about data science or machine learning. So one way of creating the model or making the model learn, so that is supervised. So I have set of data and I know the result. So this data belongs to this result or this level. And based upon that, I create a model. Model can be many things. It can be like a neural network, or it can be like naive Bayes, or it can be like k nearest neighbor. Okay, there can be many ways of supervised learning. So we know the data and we know the label against each sample in the data. Now the sample will have features. There are deep analogy in the when we talk about the feature. But okay, just we say that a sample has set of features or properties and it has a target. Means it belongs to which sample. Target is also a feature. So a sample has set of property and one property, we can say it is the target. Others are feature, but anyway, the way it is written in books. So a sample has set of features and it has target. So we have supervised learning. But there are many scenarios where we are not interested in labeling, or either label is not available or we are not interested in labeling. Okay, like I can be something like handwritten. Okay, so I have a set of questions. Okay, and on a page of paper. I don't enjoy typing. So on a page of paper, I wrote question, answer, question, answer, question, answer. So there are two categories, question and answer. And like that, I wrote 200 questions and answers. Okay. Then suddenly I felt that these are going to be given to the students. So they cannot see the answer. So I need only question. But this is how I prepared question and answer. Now if I scan it, then manually I have to take out all the questions. I have to open image editor and then cut all the questions and place at one place and give it to the examiners. So means it may be time consuming. because I have prepared question, answer, question. I mean, that is the natural way of preparing questions. So question and answer. Now I want to take out all the questions separately and all the answers separately, or in a document. So there are two sections, question and answer. I have 10 sections. So 10 section, 10 section, 10 section against each item. Now all 10 I have to place in 10 different places. So how we can do? Means if I scan that question and answer, then basically there are three kind of colors we are getting. One is the white color of the page. One is the question color. So I consider question I have written in dark or in black, and answers I have written in kind of blue, or questions I have written in bold, or questions I have written in bigger font, and answer I have written in smaller font. So there are differences. But among the white page only, if I scan and get the pixel color, then it would be different. So I cannot say in the program that if pixel color is white, then it is a sheet. If pixel color is 0, 0, 0, then it is question, and pixel color is RGB. So 2, 2, 2, then it is the answer. Because if I scan it, then color would change. If pixel color is in this range, or this range, that much, if I start specifying, error prone and time consuming. Okay, now we have labeling. So labeling is there. So one pixel belongs to white sheet, one pixel set of pixel belongs to question, and one set of pixel belongs to answer. So there are three labels, but we don't know. Means if I scan the notebook, which pixel would go where, that I don't know. This comes under unsupervised learning. So in unsupervised learning, we have the samples. So, but we don't know the label against each other. So one way, so there can be many ways we achieve in supervised learning, like dimensionality, dimension reduction, or expectation maximization, and there can be many ways. One way that is the simplest is k-mean. Okay, so that we'll see that how we use k-mean to kind of in a scanned paper to take out all the questions against it is written in question and answer pairwise. Okay, now if I see the k-mean, so k-mean is kind of amazing. It is a very similar to like we see the quicksort. So where we keep shifting the mean, and then we take out whatever is big to right side and whatever is less on left side to the mean, and then we keep doing. So it is not recursive, but still the idea is similar, that if I have a data like here, what we talked about question and answer in a white sheet, then data are in three groups: all white pixels, all bold pixels that are questions, and one non-bold pixel. So all three, they can be categorized in three sections, or I can say area where there is no coloring, and area where there is coloring, and if I find out the width of the text somehow, then bigger width text and smaller width, whatever way we want, or we can mix everything together. So in k-mean, so there are data what we receive from the scanning the paper, so that we estimate that there is a k. K means how many kind of groups are there. So I can say there are three groups. So I can say three groups. If there are three groups, then randomly I place the mean of the three groups, I mean three clusters somewhere, and then we try to place all the pixels. So suppose that I place all three mean at 1.1, then I try to find out all the pixel that is near to a particular mean, or if it is not at one point, near to each other. So all pixel near to a particular mean, all pixel near to a particular mean, all pixel near to a particular mean. So it can be kind of random, and it cannot be clean solution. Okay, now we decide the three clusters, that where who belongs to whom. Now once three clusters are done, then from all three clusters we find out the Euclidean distance between each point in the cluster to the mean, and then we shift the mean at the center, possible center of the cluster. But since our cluster, 3 clusters are different, okay, it will be kind of messy. Okay, then again we repeat the same stuff. Now we got the mean and we got the 3 clusters, then again we'll try each point in the cluster to the nearest mean. So it will start shifting because obviously the cluster are placed at different places. So mean would start shifting at its position, and the samples which are actually they are near to the mean, they will start belonging to the mean. So this is something like we first we select the mean, and then we select the clusters, and then we shift the mean. Once we shift the mean, then clusters are not the actual cluster what they were earlier. Now each sample they may belong to different mean because mean has shifted, and this way we keep doing, and at the end we will find that there is no much shifting in the mean from here and there. Then we come to a conclusion that we have 3 clusters and we have found the mean. Once I find the mean and I find the cluster, then whatever pixel I receive in the scanned copy, then I can do the logic and find out what the question is, and I can segregate. So that is the idea that we will use in the K-mean. Okay, so that is one scenario. How I find the number of centroids or number of mean. So that comes to a question, because if I have a random data, here I know that I have 3, but there can be like question, answer and hint, question, answer, hint. So hint maybe there, may not be there. So in that way there are 4. So in that case we cannot say that mean count is 3. So in that scenario we cannot say what is K. So we have to determine what is K. Okay. So that we'll see that how we can determine the K. So number of the means, like if I say I have only one mean, then if I have one mean, then I find the mean position nicely, and then from each point in the sample I'll find the average distance. Okay, I call it error. So if I find the average distance, that will be high. Now, like in our normal example where K is 3, now if I say K is 2, then again there is a kind of large shifting of the mean would happen. It will not be natural mean. Again the distance would be larger. If I say 3, then the distance of each cluster samples to their mean, each cluster sample to their mean, each cluster sample to their mean would be minimum. Okay. Now if I take 4 mean, then it will be again even less. If I take 5, but at the point at a 1, if I keep the mean at one location, then distance will be very high from each sample to the mean. So the error would be very high, error would be less, error would be kind of minimum, and then so it creates a kind of elbow kind of how I can say. Okay, so it is kind of elbow where drastically it goes down and then it becomes almost parallel. If in calculus, I would say if I get the equation of the line, then dy by dx means where the differentiation is 0, around 0 or the minimum. So that is the K. So that equation, that idea that also will bring. So we will develop elbow equation also, where we'll take the angles and where angle is the maximum. So that is the K. So all this scenario, finding out the optimum K and then finding out the K mean all the centroid and then their clusters, and then in the question answer we will have practical question answer that we'll scan, and then that we'll see that how we'll take out the question. This is one thing. Second thing is that sklearn has ready-made algorithm based upon for the K-means. So we will differentiate that how much difference we are getting from the what we write from our own hand, the algorithm, and what is available through sklearn. So K-means in the data science. So with the real life example, I need it. So it's not that I have copied from anywhere from internet. Probably it will not be there at all. So that will.